Regulation of the IV fluid flow. So infusing IV fluids by gravity or an electronic infusion pump is typically how we've got those one or two options. To ensure therapeutic effectiveness of IV fluids, a constant, even flow is necessary to prevent complications from too much or too little fluid. A physician must order a rate of IV infusion or fluids or medications. The rate of the infusion for medications given via a secondary or primary infusion can be found in the manual, Parenteral Drug Therapy Manual. If an order for IV fluids is to keep vein open, or KVO, the minimum flow rate again is 20 to 50 mLs per hour, or according to physician's order. A healthcare provider is responsible for regulating and monitoring the amount of IV fluids being infused. IV fluid rates are regulated in one of two ways: via gravity. The healthcare provider regulates the infusion rate by using a clamp on the IV tubing, which we showed you in another lecture. This can either speed up or slow down the IV rate by rolling that clamp shut or open. An IV flow rate for gravity is calculated in GTTSs, which is drops per minute. Electronic infusion device, or an EID. The infusion rate is regulated by an electronic pump to deliver the fluids at a correct rate and volume. All IV pumps regulate the rate of fluids in mLs per hour. An IV pump is used for many types of patients, solutions, and medications. It's what you will see 95% of the time, if not more. An IV pump must be used for all CVC devices, all opioid infusions, all pediatric patients, all medication as described in the PDTM, and infusion rates below 60 mLs per hour. And here's a picture of one type of IV pump with two channels on the side. To calculate the drops per minute for infusion by gravity, these are the steps you would follow. Well, you would verify the physician order. So an order may read to give normal saline IV 125 mLs per hour. Another example may be give 1,000 mLs of normal saline IV over 8 hours. You would have to figure that out. And then you would figure that out by using the drop factor, okay, which is on the IV tubing. And it's either 10, 15, or 20 drops per minute, meaning how big the tubing is and how many drops it's capable of dropping wide open, okay? And then there's a micro tubing, which can give 60 drops per minute. The drop factor or calibration of the tubing is always on the IV tubing. We don't really do this anymore. This is very, very rare, but there are instances where you will see this, and it's more in home health than in the hospital. So this is the formula you would use to calculate how to do a gravity. So the formula is actually very simple. It looks complicated, but here's an example of infused normal saline in 125 mLs per hour. The IV tubing drop factor is 20 drops per minute. So you're going to take the 125 milliliters per hour, which is 60 minutes, and the drop factor is 20, and then you do the math, and then it would be 41.6, and we would round it up, meaning back in the day we would sit there with our watch and the roller clamp and count the drops in that drop chamber to make sure we had 42 per minute. Oh, it was so tedious. We would, again, like I said, regulate this, and I will show you this in class just so you could see what we used to have to do. We don't do this anymore. Typically, it's usually done via a pump or a syringe pump or a dial of flow. There's all different ways that we do this via than just gravity now.